So this is lesson 4445 day C, and in this one, just to check where you're at with this stuff, this is, well, that's our side angle side properties, but I want to look at this one with you. So to do these problems, these are proofs, and we're going to be using side angle side, side side side, all of those postulates. So when you do these, think of these: side angle side, side side side, angle angle side, angle side angle. So somewhere in these proofs you're going to have these postulates being used, and you have to have three things always: either a side, an angle, or a side, or a combination of all of those. So you have to look in the picture and see where there's three things. So for this one, it says L is the midpoint of WE. So the first thing I do is I just start marking up my drawing, and then it says WR is parallel to ED. That reminds us of the last chapter. Remember in the last chapter when we talked about alternate interior angles? So there's some alternate interior angles, and then look and see, is there some other thing that we know of that we can add any congruencies on here? And I think there is with this vertical angles right here. So those two are congruent to each other. So now let's go and write our statements. So if you were to explain this to me, you probably could do the same thing about why those are congruent to each other. And this looks like it's going to be angle, side, angle. Because again, the side is right immediately and on the same line as those other angles. Okay, so first we write the given. L is the midpoint of WE. And then WR parallel to ED. So the reason is given. Then we go and start just listing the things that we're already talking about. Because L is the midpoint of WE, we also know that WL is congruent to LE. Those are line segments. And the reason for that, this is the reason, this is the midpoint theorem. So you got to know these theorems. I know it's a pain to memorize them, but you just have to. It's just how we do it. Okay, then the next thing is, so that's one of our sides, right? A side of a triangle. So the angle in the middle at angle L, where the L is, we know that angle RLW is congruent to angle ELD. So that's the vertical angle theorem. So that gives us the angle. So then number 4 is we need the other angle. Wait, we've got our angle, we've got our side, now we need the other angle. So this has to do with the alternate interior angle ones. So this would be the angle RWL is congruent to angle DEL by the alternate interior angle theorem. So this is the other side, the other angle that we're looking for. Okay, so in the picture it's in order of angle, side, then angle. So by angle, side, angle, we know that triangle WRL is congruent to triangle EDL. Angle, side, angle. Okay, so again, you just take your picture, mark it up, think about it, and then start listing your reasons. Okay, so here's another one. Sometimes these are easier if you go and you separate them out. So over here to the side, I'm just going to write these over here actually. So here's J, N, M. And then this other triangle that we're looking at is K, L, N. Okay, so right off we know that angle NKL, so NKL, that's this angle, is congruent to NJM. That's a given. We know that KL is congruent to JM. That's a given. And then we also know, don't we, that this angle N is congruent to itself? So much easier when you separate the picture out. Okay, so then it looks like this one might be an angle, side. Okay, and this is angle, side because the side is not in between the two angles. So we do our given, angle N, KL is congruent to angle N, JM, and KL, line segment, is congruent to line segment JM. The reason, it's given. Okay, the next thing that we talked about, the easy one is angle N is congruent to angle N. Okay, that's by reflexive. And that's the angle that we're after. Okay, so we've got one of our angles of angle, side. Then third, the other thing that we talked about is, and this is our side. So there's our side. And then the other one is our angle, right? So then we have our angle and our side, right? So now we just say that triangle and triangle. So triangle J corresponds to K, N corresponds to N, and M corresponds to M, is congruent to each other by angle, side. Then we go back and check the proof statement. This time it says ln is congruent to mn. So we can actually say this now that it's true because when corresponding parts of congruent triangles are congruent, or corresponding parts of congruent triangles are congruent. So this is a corresponding part of congruent triangles, so they're congruent. So corresponding parts of congruent triangles are congruent. So this is the reason why, because it's part of those two congruent triangles. Alright, this is an isosceles triangle, so the vertex is E. That means that these two sides have to be the same, but this right here is the vertex. Okay, we also know that EG is perpendicular to ML. So we're going to write that right there. So I think we have to figure out that these triangles are congruent to each other, so let's just kind of talk it out. So if that's 90 degrees, so is that one. If this is isosceles, that angle is congruent to that angle. So now I have the hypotenuse and an angle and an angle. On this one, so here's what we do with this one. One isosceles, triangle MEL. Okay, and EG is perpendicular to ML. I'm going to write vertex E on here too. That's given. The next thing on this one, I'm trying to read my notes because I did this a couple different ways. Okay, so because it's isosceles, we know that the sides, ME, see we already talked about this, is congruent to ML. So the reason for that is the definition of isosceles triangle. Then the third thing on here is that angle MGE is, and let's see what I write in my notes here. MGE and angle LGE are right angles. That's because of that perpendicular lines. Oh, I should write that for you, sorry. Perpendicular lines intersect to form right angles. Okay, and then we're not going to use the base angle thing. I'm going to erase that because there's an easier way to do this. EG is congruent to EG. Angle M, oh, we don't even need that. Okay, so angle, so EG is congruent to EG. That's reflexive. Okay, one thing I forgot to establish with you on this one is that triangle MGE and triangle MREGL are right triangles. Okay, that's a definition of right triangles. And then the last thing is, well, not the last thing, we've got two more things. Triangle MGE is congruent to triangle, what's that, EGL. So L corresponds to M, G corresponds to G, and E corresponds to E. The reason for that is because of hypotenuse leg, because this is the hypotenuse, this is the leg. Okay, and then MG is congruent to GL. The reason is CPCTC. All right, next one. This one, given. I'm going to put it in there. And all right, this last one, I put the given in here. And then we know that BD is congruent to BD. Remember what that is? That's reflexive. Okay, the third thing on here is that angle ABD is congruent to angle CDB. Okay, so ADB is right here, CDB is, or ABD is right there, CDB is right there. Reset. Okay, so where I'm headed now is this, and then I also know that these other angles are congruent to each other too, because those alternate interior angles. So this one is because it's an alternate interior angle theorem. 4 is going to be the same thing, so I'm just going to put these marks. That's what that means there. So 4 angle ADB is congruent to angle CBD. Same thing, alternate interior angle theorem. Okay, so now I know the triangles congruent to each other. A has a corresponding to C. B is corresponding to D. And then D corresponds to B. Separate the triangles out if you don't get what that is and redraw the triangle so you can see it. Put the congruency marks on it. So this is angle, side angle. And then number 6 is AB is congruent to CD. And this is by CPCTC. Okay, so that's it. I think this one you might be able to find a shortcut around here if you look through that list of theorems and proofs, but